the problem is a tank, and it's given the 2 point for you. But in case that you don't have the 2 point, don't forget, you should choose the 2 points. Me, myself, always use one of them on a surface. The other one on an exit. That's the easiest. And it says that H is 1.8 meter. The diameter here is 0.2 point. And what does it ask? Find the flow rate, which is Q. Or first, you should find velocity. In case that you forget the Bernoulli, P1 over gamma, Z1, V squared 1 over 2G. What would you choose for P1? Or would you cancel it out with P2 because they are equal? Okay, what about V1? What's your number for V1? Velocity at point 1? 0, no movement. Although when it's going out, the water surface comes very slowly to the lower. But since it doesn't mention about that, so we can consider that this is still water. So V1, 0. What about Z1? What would you consider for Z1? 1.8. That's correct. For these, you should have a reference, right? The easiest is the second point. I will say this is my datum. So Z2, 0, Z1, 1.8, right? The difference between elevation. And as I mentioned, V1 is 0 as well. What is V at point 2? You need to calculate it. This is the one that question asked. So we just need to figure out the P1 and P2. What is P1? Why? Water surface. Yeah, you have atmosphere here. And I told you, whenever you have atmosphere, 0. What about P2? Again, 0. It's splashing into atmosphere. So P2 is 0 as well. So you just need to write V squared at 0.2 over 2G is equal to 1.8. And that's how we can find V2. Now, what's V2? Oh. Do you have the number? Meter per second. Now try to go through the second one. Same thing, just this time says that the velocity is given to you. And oh, sorry, before that, it says flow rate. Word flow rate means discharge, means Q. And Q is equal to velocity multiplied by area. No matter if you have velocity at point 2 or 1. So I will choose the second one, because the velocity 1 is nothing that could help me. So I will go for this one. 5.94 multiplied by pi. What about D? D is 0.2 square over 4, which I think I have it. 0. Cubic meter per second. Whenever you forgot the unit of discharge, you should say discharge is volume per time. The one that you experience in the lab. Volume per time. That's the discharge. So cubic meter per second, cubic meter per minute. For the second one, it says find the head loss. Now I'm going to write more professional version of Bernoulli, which is P1 gamma, Z1, P2 gamma, plus HL. These are losses. Always add losses to the right hand of the equation. Whenever I didn't write that, it means that the question didn't mention that. I neglect that. It was small, or I didn't have data for that. But right now it asks me to find that. Again, same situation. P1, 0. P2, 0. V1, 0. Z1, 1.8. Z2, 0. Instead of V2, put the number that's given to you. So 1.8 from this side, 5.2 from this side, square over 2G plus HL. Now find HL here. Found it? Cooper, although either talk or just try to solve it by eyes. I noticed that. You're just looking at the problem and think that it's going to solve like automatically. Yeah. Super smart. Yeah. Just look at that. Maybe 5. Did you find it? Your answer is 0.3? No? 0.42 is the correct one. Here we go. These are the answers.